Happy New Day to you. Here is the concept for today, solving equations involving factorial. And we're going to go through three examples, three factorial equations that we're going to solve, and it's going to get progressively a little bit more difficult. All right, example one, we have this equation, n plus 1 factorial in bracket, divided by, in bracket open, n minus 1 factorial equal to 30. All right, the first thing we got to do, we're going to make sure to break down the larger value, and the larger value is n plus 1 is bigger than n minus 1, so we're going to go ahead and break that down. So here it is, that becomes n plus 1 times n times n minus 1 factorial and divided by n minus 1 factorial. Remember that, let's set that equal to 30. Remember that we stop at n minus 1 factorial because there's n minus 1 factorial in the denominator, so we can simplify. And now we're going to go ahead and simplify that. So n minus 1 factorial, n minus 1 factorial divides. So we get n squared plus n. So I'm basically doing a distribution of each of the terms equals to 30. Then we have n squared plus n minus 30, set that equal to 0, and it turns out that this is a quadratic, so we can factor it, or you can use quadratic formula, but if you factor it, you get n plus 6, n minus 5, set that equal to 0, and the zero product rule tells us that one solution is n equal to negative 6, or n equals, that's the second solution. Now we're going to go ahead and check, because remember, n, any type of a factorial has to work, and the value of a factorial, if you have n factorial, n must be greater than or equal to 1. It cannot be 0, it cannot be fraction, and it has to be integer. And negative, of course, it cannot be. All right, so here it is. First of all, when you plug in negative 6, you will get negative 6 plus 1 for the numerator, that's factorial, over negative 6, negative 1 factorial, that's equal to 30. Well, this is an issue right there. You have a negative 7 factorial, and a factorial cannot be negative, so this is not the integer solution. So here, n equals to negative 6, not a solution, but n equals to 5, when you plug it in, will be the only solution, okay? And you can double check that. On top, you get 6 factorial over 4 factorials, and that is, when you divide the two, you get 30. All right, so that is it. So in this case, we have only one solution, and the one solution is n equal to 5, right here. All right, let's look at the second question. All right, so we have this equation. So again, which one of the two, in the numerator and the denominator, which one of them is bigger than the other one? Well, the 2n minus 1 is bigger in terms of value than 2n minus 2. So we're going to break the top down. So here it is. So we get 2n minus 1 times 2n minus 2, and then factorial. Remember, descending by 1. And then the denominator is 2 times 2n minus 2 factorial. Okay, so now we're going to go ahead and simplify. So 2n minus 2 factorial, 2n minus 2 factorial, that is actually divided, and that's, by the way, set at equal to 10. And now we have 2n minus 1 divided by 2 equals to 10. And now we're going to go ahead and do the multiplication. You get 2n minus 1 equals to 20, and then 2n equals to 21, n is equal to 10.5. Now, once you get this, you need to check the domain, okay? And what I mean by domain is the values where the factorial makes sense. Well, we cannot have fractions, we cannot have negative number and we cannot have zeros. All right, so let's go back up there and let's see when we plug it in what will happen. So here you go check. So we have 2 times 10.5 minus 1 factorial divided by 2 times 2 times 10.5 minus 2, close the bracket, factorial. Is that equal to 10? Okay, and from this point on, you just have to do the math and then find the answer. So simply you plug in n equal to 10.5 back into the original equation, which is right up here for n, and then you do the math, and I put that in there, and then you get equal to 10, and then you have to simplify the inside the bracket. You get 21 minus 1 factorial over 21 minus 2 factorial in the bracket times 2 in front, and you get 20 factorial over 2 times 19 factorial, because 21 minus 2 is 19, that's 19 factorial. And now you can actually use your calculator, but you can actually do a freestyle, the 20 on top, so we can break it down. That would be 20 times 19 factorial divided by 2 times 19 factorial. The 19 factorials, they're common factors. 20 divided by 2, that is 10. Fantastic. So n is a solution. Now here is the little common mistakes some students make, is that they look at this value here, n equal to 10.5, and they say, well, n factorial cannot be fraction, or n cannot be fraction in n factorial, right? So in n factorial, n must be greater than or equal to 1. All right, so it cannot be negative, it cannot be 0, it cannot be fraction. But then remember, this is in a context of n factorial, not in a context of this equation. All right, so this n is just a value. You plug this number back in there, and if this works, then you're good. So inside of this, you get 20 factorial and 19 factorial when you plug in the n value, and that's okay. So you're good. So make sure that you double check. So don't just look at it and say that's a fraction, decimal, that's not an answer. That's not true. It has to work within the equation, and the factorial needs to make sense. So in here we have 20 factorial, 19 factorial. All right, next one, the last question. Here it is. We have this equation, and again, which one is bigger? Either the denominator and compared to the numerator. So we have to break down the numerator. So here it is. We say n times n minus 1, and then times n minus 2 factorial. I am not going to continue to n minus 3 because there is no utility to that. So there is no n minus 3 down in the denominator here as a common factor. So that's why I stopped at n minus 2 factorial. I mentioned that in the last video as well. So over, and then 2 times n minus 2 factorial, set that equal to 21. All right, common factors, n minus 2 factorial, n minus 2 factorial, they divide, and then what you will get is n times n minus 1 divided by 2 equals to 21. And then from this point on, you have to do the math, n squared, and then multiply through minus n, that's 42. And then we have n squared minus n minus 42, set that equal to 0. And here again, you can use quadratic formula or factoring technique to solve this. You get two brackets, open up, n and n, and that's minus 7 plus 6, set that equal to 0. Two answers, n equal to 7 or n equals to negative 6. All right, now we're going to go ahead and then check. Make sure that it falls within the definition of the factorial. So first of all, right away, when n is negative 6, you plug it back in there. Notice that you got negative 6 factorial. There is no such a thing. So you can immediately reject that value. So that's not an integer value. That won't work. N equal to negative 6. But the other one, 7, will work because 7 factorial is okay, and n minus 2 is 7 minus 2 is 5. 5 factorial is okay, and then the values will work for n equals to 7. So n equal to 7 is the only integral solution. All right, very nice. Check out the next video about permutation and a combination that actually uses factorial notation and factorial computation. All right.